Hi, welcome to Vegetable Calculus. We are now dealing with two-dimensional calculus. Now let us say if we want to find the area of this onion slice. As usual, we need r and theta. To determine the limits of integration, say for theta, we need to freeze r. And because it's two-dimensional calculus, we need double integrals. And also because it's an area integral, we need double integrals. And let us set a particular r, because r varies like this. R is equal to 1 is that small circle, R is equal to 2 is this middle circle, R is equal to 3 is this big circle. So particular R is a particular circle. So let's isolate one of them. Say this is a particular R. Because we froze R, we can determine the limits of integration for theta. Theta varies from 0 and so on till 2 pi. So theta is 30 is here, theta is 90 is here, and so on. So it's tracing at this point, this point, this point, this point, this point. It's tracing all over. When theta comes to this 2 pi, it traces the entire circle. So limits of integration for theta are 0 to 2 pi. So this gives us the length of only this particular circle. But we are trying to determine the area. So we need the other rings too. We need the length of the other rings too. So now comes the better question. What are the limits of integration for radius? Because we want theta to trace over all of these to determine the area of this onion slice. The radius should vary from 0 till the radius of this outermost circle. Let us say the radius of the outermost circle is 10. So if the radius varies from 0 to 10, for each of these rings, for this ring, theta varies from 0 to pi, and for this outermost ring, also theta varies from 0 to 2 pi. For the intermediate rings, also the theta varies from 0 to 2 pi. That covers the length of all these circles, and finally that gives the radius. That gives the area. We know the area element is r dr d theta. If you evaluate this integral, that will give the area of that onion slice. So you can do either of them first, r dr, and then use these limits of integration, or you can evaluate d theta and use 0 to 2 pi as the limits of integration, because r dr is not connected with theta. But the problems that I'm going to talk about later, if they are connected with each other, like r has a formula in terms of theta, then you want to evaluate from the outermost to the innermost integral. Okay, we'll talk about them later. For r dr, the integration is r square over 2. The limits of integration are from 0 to 10. And similarly for d theta, the integral is theta and the limits of integration are 0 to 2 pi. So if you multiply these two, like evaluate this one, that will give the area of that onion slice. So r square is 100 over 2. I'm not bothered about that 0 because 0 doesn't add any value to this integral. Similarly, theta is 2 pi. So if you cancel these two, you get 100 pi. That's the area of that onion slice. Thank you for watching. I'll use more interesting vegetables and find their areas in the next videos. Thank you. Bye.